Okay, more on normal distributions. The beauty of this video is I'm not going to really teach you anything new. We're just going to put some notation. Uh, I'm going to introduce some notation. I'm going to match it with things we already know how to do. If you understood the content in the previous videos, so you can see I got the my notes up on the right, and then over to the left I have StatCrunch, and I'm going to show you how to work some of this stuff. Okay, and again, really, the beauty of this video is we're not going to do anything new. We're just going to put some notation on things that we hopefully already know how to do. So, what does this statement mean? This statement means that ACT scores are approximately normal with a mean of 21 and a standard deviation of 15. So I can think when I see that mu equal 21 and sigma equals 5. Now, we talk a lot about percentile ranking as a location. And the problem I want to start out with just is a question. What is the percentile ranking for an ACT equal to 25? This is one of those things you just have to remember, tattoo it to the brain, as I like to say. It's going to be one of those things that, okay, like on your first exam, your midterm exam and your final exam, you're going to get to use a sheet of notes. You get a cheat sheet. This will be one of those things that you'll want to definitely put on your cheat sheet. So it needs to go uh, in your notes. So what needs to go in your notes? That when I ask, well, when anyone asks for a percentile ranking, all they are asking is what is the percent below. Finding the percent below is the same thing as finding the area to the left. So finding the percentile ranking, the area below, the area to the left of, all asking the same thing. So you can see the drawing I have down here for 25. I need to find the percentage below 25 to the left of 25 to get the percentile ranking. We should know now that that's really easy to do with StatCrunch. Just go to the normal model, put in the correct mean and standard deviation. We want below, so select less than, and I want below 25. So we usually round percentiles unlike percentages or proportions where we, in this case, I would just, if I was just going to find the area to the left, I would report 0.7881. But what we typically do with, how we typically report percentiles would be to the nearest percent. So then I would say here, this would be the 79th percentile. So if you're walking down the road and someone wants to know you took a test and the mean was 220 and the standard deviation was 18, and you tell them they're at 260. Well, in isolation of anything else, a score of 260 doesn't mean anything, right? Definitely not a percentage. And unless you know the metrics of the test, you don't know what that means. But once you say you scored at the 79th percentile, whether it's an IQ test, whether it's an ACT, whether it's SAT, whether it's cholesterol level, whatever it may be, the 79th percentile tells that person that 79% of the scores in that distribution are below your score. Okay? So again, that's all percentiles are, percent below. Now, we take a little different approach. How does this compare? Let me see if I can get this clear. Yeah, that's a little bit better. When I put my hand in there, it just messes stuff up. Anyway, how does this compare to P80? Now, P80 is asking you to not find the percent below or the area to the left or the percentile. It is asking you to find the value that corresponds to having 80% of the scores below. So again, percentile, tattoo it to the brain, percentile equals below. That statement is giving you a location relative to the percentage of scores that were below. So if I'm going to find a score at the 80th percentile, For the ACTs, I'm going to keep my mean, I'm going to keep my standard deviation, but I'm going to come in here and put a 0.80 because again, the 80th percentile is percent below. Make sure I have this less than or equal to. Hit compute. So it would be a score of 25. Now, because, 25.2 and 25.6 are all recorded as 25s, the 78th percentile and the 80th percentile would give you the same ranking, same percentile ranking. Let's just, what's the 35th percentile? 19. What's the 99th percentile? 33. What's the 92nd percentile? This is where my daughter actually uh, ranked. Actually, she ranked higher than that, but she got a 28 on one of her tests. What's the 14th percentile? 16. What's the 22nd percentile? 17. I think you get the gist here. All right. So again, percent below, and just don't get sloppy and put greater than there. If you do, well, you're going to miss it because you have to put less than for percentile. Next thing I want to cover in this video are called critical values. Now, looking ahead, this is in lesson 5, but looking ahead, we're going to run into things called confidence intervals, and this is under the whole estimation process where we take a mean and we add and subtract margin of error. Well, the margin of error is found by taking this, what we call a z-critical times the standard error. So look, what I want to talk about, I really don't, right now, I don't care much about this, and I don't care much about this. We'll get to that soon enough. What I want to talk about is that critical value that we use in test of inference, confidence intervals, hypothesis testing, lessons 5 and 6. And instead of looking at like z alpha over 2, I just want to talk about what is z over alpha. We'll get to that stuff. It's not a stretch. Once we learn this, it's not a stretch to learn this. So let's talk about what is z over alpha. Z over alpha is the score that has alpha area to the right. It's the score that has alpha, and this little symbol right here is the alpha as well. So alpha, I'm giving you the symbol to the right. So z of 0.10 is the z-score that has 10% of the area to the right. Now, can we find that using a normal calculator? Well, absolutely we can. We know that the mean and the standard deviation of z-scores is 0 and 1. Once we start working with z-scores, we move into what's called the standard normal distribution. By definition, this is above, and I need to find the z-score that has 0.10 above. So that's going to be 1.28. So that is z subscript 0.10. Again, it's just one of those things that you have to, once we understand with StatCrunch how to find area above, an area below, an area between, then it's just a matter of putting some symbols with our work. Z.10, find the area above. Z.92, find the area above. Z.67, find the area above. All right? These stats doesn't have to be hard. We just make it hard. You're like, yeah, all right. All right, Z of 0.95. Now, 95%. So what is Z of 50, 0.50? Well, it's got to be 0, doesn't it? Because we know that this is a symmetric distribution, uh, smack dab in the center. So 50% above and 50% below. So if I ask you what's Z of 0.5, well, let's just do it. Maybe you don't believe me. Well, it's just the mean, right? So by Z of 0.95, I know that I've got an area bigger than zero point 0.5, so I know that the answer to this problem must be negative because to the left of 0, these are all negative z-scores. And for the reason I just explained, my area being bigger than 50%, I know that I'm residing in the negative z-scores. So above 0.95, negative 1.64. All right, and when you do these problems in my stat lab, just make sure you round accordingly. Now, I said something earlier that I want to just kind of add on here at the end. We haven't talked about much beyond in a normal distribution. We haven't discussed much more than the mean and the standard deviation. But what would these values be? What would the median be? What would the mean, the mode be? And what would the variance be? Well, by definition, the median is the value that's smack dab in the center. So for the standard normal distribution, the median would be 0. For a regular distribution, for example, let's go back to the, let me see if I can find it here. Let's go back to the ACT scores. What value is smack dab in the center? The 21. What role does that 21 have? It's the mean, right? So the median in the standard normal distribution is equal to 0, which is the mean. And in a regular non-standard normal distribution, the median is just the value in the center, which is the mean. What about the mode? What you got to remember when you think about the mode is this curve comes from a perfectly scripted, a perfectly drawn histogram. Well, what do the height of the bars represent? Frequency. Well, which value would have to align with the mode? The value with the highest level bar. And where does that have to happen? Well, it has to happen in the center. So the mode is also 0 in a standard normal distribution. And it's also at the mean in a non-standard normal distribution. So for the ACT, the mean was 21. So 21 is going to be the mean, 21 is going to be the mode, and 21 is going to be the median. How's the variance compare here? Well, remember the variance is just the standard deviation squared. So for the standard normal distribution, the standard deviation is equal to 1, so the variance would be just equal to 1 square unit, which there are no units in the standard normal distribution, so the variance is just 1. What would be the ACT variance? Well, the standard deviation, what did I tell you, 6 or 5? Yeah, 5. It varies from year to year. I've seen the standard deviation on ACT scores range anywhere from 5 to 5.1. They're up now. Recent years about 5.8 to 6. But given the information you have, where the standard deviation is equal to 5, and the variance is just that value squared. So the variance would be equal to 25. All right, gang, that's all I got. Again, really nothing new here, just kind of solidifying some things and putting some notation with some things that we already know how to do. All right, take care.